Okay, now this exercise is going to be a really important exercise because it's going to show you some common features between all the different graphs you've looked at. And you may be thinking, well, what could be common between an exponential and a straight line? It's not so much in the shape that we recognise the common feature, it's in the connection between the impact algebraically and the graph. So for all our functions, they're all written algebraically and they all appear graphically as their known shape. What we do is we look at changes to the algebraic forms. And when I say that, for example, if I was to look very simply at y is equal to x squared, and then I make a change like y is equal to x squared plus 3. So I've made a change in the algebraic form. And that change is to add a constant to our basic function. So what we've done then is said, well, the impact that adding that constant has on that parabola or that quadratic, is that the same as when I've got y equals x and then I do the, y equals x plus 3? So I had my basic graph and then I did this same change, x plus 3. Or if I had y is equal to x cubed and then I made this same change plus 3. Or if I had y is equal to 2 to the x and then I considered y equals 2 to the x add 3. So it's this sort of change that we're going to investigate. Now, some of the changes are as simple as what happens when we start with y is equal to x and we simply look at the impact of putting a negative in front. Or y is equal to x squared and we look at putting a negative in front of it. Or y is equal to, x squared, that should be, x cubed and putting a negative in front of it. And so on. What is the impact of the negative? As opposed to, what is the impact of putting the negative inside the bracket and then cubing it? So this is our basic function. This is putting a negative in front of the whole thing. This is just impacting directly on the x and then cubing it. So there's lots of different, and we would call them almost translations. So the translation could be to add a negative, to add a constant, to subtract a constant, to multiply by a constant, lots of different sorts of translations. And interestingly, they have similar impacts, even though we talk about the different functions. They still have the same impact. Even circles, you'll learn that the impact of a change directly to x and a change directly to y will have the same impact on a circle as it does on any of these other graphs. So it says here, there are some features of the function that result in a simple movement of the graph from its original position, from its most basic. And so I would say this is the very basic parabola. And then if we make a change to this, then we see a movement of the graph. These movements are called transformations. Just be aware of that word, because you might hear me use it. You might hear me in the future say, remember the adding a constant will transform it to the right or to the left, whatever. And recognising these features, these common features, make sketching functions much quicker. So, what moves the function left and right? So here's our original, this is our original, and this is where it sits, and most of us know this now, that y equals x squared has its vertex here. How do we take that exact same shape, but now move it over here to have its vertex at 1? Now you might think you would add 1, but it's the exact opposite. You need to have x minus 1. Now, that is different. It's a different function to if I was writing y equals x squared minus 1. We will see the impact of that in a moment. Subtracting 1 to the whole function is different to impacting directly on the x with a minus 1. So, yeah, you can see that if you put a minus 1 in this position, it moves the vertex over to the right 1 unit. And if you were to put a 2, the graph of y equals x plus 2 all in brackets squared, it would transform your original graph to 2 units now to the right. Oh, sorry, no, plussing. We're plussing now. It'll move it 2 units to the left. Interestingly, if we had y is equal to x cubed, now we know that that sits here. If I was to be asked to graph y is equal to x, I'll do a plus, which will move it back, x plus 2 all cubed. Now, plussing the 2 moved it to the left, subtracting a number put it to the right. So now this cubic should be moved back 2 units and maintain exactly the same shape. So back 2 units, same shape as your original cubic, which went on down here and on up there. As you just heard, the bell rang, so I'm going to stop this video here, and I might do the exercises with you in class, or do these, fill these notes out, and I'll do a video on the next transformations.